Hey, welcome to another video. In this video, we're going to talk about the Keccak256 function or hashing algorithm, however you want to call it. I'm calling it a function because it is a function that we use in blockchain development, more specifically in the Ethereum ecosystem, to hash basically pieces of information, data, even functions with their name and the arguments that they take to create what is called a function signature. Now, if you know nothing about the Keccak256 function or hashing algorithm, that is completely fine because that is what I'm going to do in this video, or at least attempt to do so. I'm going to try to explain the Keccak256. Oh my goodness, that is some horrible handwriting. What I'm going to do is explain the Keccak 256 function for you. I'm going to give you an explanation of what it does, when would you use it, and then we're actually going to go into Remix, which is an IDE for blockchain development, and we're going to see an example live. Okay, I'm going to write a little function, very simple function, just so that you can see how to use the Keccak 256 function in a development environment. Okay, so without further ado, let's actually get into it. What is the Keccak 256 function? The Keccak 256 function is a function that allows you to hash data. Okay, we can use it, like I said, with strings. We can use it with even like functions, but it allows us to hash a specific piece of data. And there are several important things about this hashing algorithm or the hashing methodology that the Keccak 256 function uses. Basically, this hashing, one of the very important things is that it's deterministic. If you don't know what deterministic is, it basically means that the same input will always give us the same output. So it is very important for you to understand this. Deterministic just means that, for example, if we throw in the hashing algorithm the word or the string hello, this will give us a 256-bit output that for the word hello will always be the exact same. Okay, that is extremely important. Another thing to have in mind with the Keccak256 hashing algorithm is the fact that it will always give us a 200, like I said earlier, 256-bit or 32 bytes output. Okay, always. And any little tiny change in the data that we throw into the function will produce a massive, like I'm going to put it in capitals, massive change in the output. We can see this with an example later on, but essentially with the Keccak 256 function, you will always create the same output for the same input, and any tiny single change, even one letter, or adding a like another letter or a number or a symbol, any single very minimal change within the input will drastically change the output. And we can see it with an example later with the function that we're going to write in Remix. So what is the primary function for the Keccak? Let me pull this down a bit. What is the primary function for the Keccak 256 function in during development or the algorithm? Like why do you want to use the Keccak 256? So it basically does two things. It basically ensures data integrity, and it ensures data security, which is extremely important, right? I mean, it ensures the data integrity because at the end of the day, it is very difficult to reverse engineer the process. Like you can know what output a specific input is going to give you, but it is very difficult to know based on an output what the input is that created that specific output. It is super difficult to reverse engineer the process. And the next thing that it does is ensures data security because of this specific reason. It is extremely important to have privacy when it comes to data, especially when we're dealing like in blockchain with private keys and stuff like that. It is extremely important to keep data secure. And with the Keccak256 algorithm, what you can do is keep that data secure because of that integrity, because it is very, very difficult to reverse engineer the process. You can almost guarantee that a specific 32-byte output created by the Keccak256 function, hacker, a malicious agent is not going to be able to reverse engineer and find the input that created that specific output. Okay, so it is extremely, extremely important. So, who really uses the Keccak256 algorithm, in what environment, and why would they use it? Well, first of all, developers. Okay, developers. Why would developers use the Keccak256 algorithm? Basically, they would use it under obviously a development environment, and they would use the Keccak 256 function. Okay, this is a specific function that is built in, or not built in, that is available when developing a blockchain application. And like I said, we're going to go into Remix and I'm going to explain it in a bit more detail. But like I said, it works exactly the same as the algorithm because that's what it mimics, right? That's what the ultimate goal of this function is to produce an output based on an input following the Keccak256 algorithm. And yeah, you can use it to basically encode data. Okay, you can encode data. Like I said earlier, you can encode strings, you can encode functions, you can encode basically anything. Okay. Another basically group that would use this algorithm or function would be smart contract developers. Now, I have been developing smart contracts for a while now, and you use it a lot. You use it for example, signatures. Now, I don't know if you've ever signed a message using a wallet like MetaMask or anything like that, but you need to verify that the public key matches the private key of that specific user to basically verify that the user that is signing that transaction is the user that is signing the transaction, right? You don't want a user that is not the user that is meant to sign the transaction signing the transaction. Okay, so it's very, very important for, like I said, signatures, and basically smart contract developers will use it to match different pieces of data. Like I said, signatures. You can also use it to create function, what are called functions signatures, okay, which is a 4-bit unique identifier for the function that is being encoded. So yeah, basically, smart contract developers will use it for a lot of different things. Okay, there's a lot of different scenarios where smart contract developers would use these function. Then obviously, blockchain users can really benefit from this. Blockchain users, my goodness, my handwriting is awful. Basically, to ensure the immutability, whoops, immutability is got two M's, immutability of the data. And then all of this comes back to basically making a network that is safe, a network that is secure. And then obviously, cybersecurity and cryptography professionals, okay, to basically develop applications and protocols that are secure. All of this is very cool, but the real learning comes from actually seeing it live. Okay, so let me pull up the Remix IDE right here. Okay, and if you've never worked with Remix, it is very, very simple. It is very straightforward. You just basically create a workspace, create a contract, and if you've never worked with blockchain development before, I mean, you have to get familiar with what a contract is, how to develop, and how to deploy smart contracts on chain and stuff like that. But for this very, very simple example, you don't even need to do anything. Just kind of follow along with me. Just see me write the code. the first thing that we need to do is obviously specify the license that we need to or that we want to use for this specific contract. Then we need to specify the specific Solidity version that we want to use. If you've never worked with Solidity, it is basically the language that we're going to use to develop smart contracts. Okay, and then we write our contract name. Let's call this. I think I call this. Oops. What am I doing? Yeah, simple contract. Simple contract. Now we're going to open the brackets and we're going to write a function that is going to be called get hash, for example. Get hash is going to take a string. Strings always have to be stored in memory. Now, if this is not making sense at all, that is completely fine. I don't expect you to know any blockchain development whatsoever. This is going to take an input as an argument. We're going to make this public pure. This is going to return a bytes 32, because remember that the oops, this is returns. Remember that the Keccak256 always returns or always produces that 256-bit output, which is equivalent to the 32 byte output as well. Okay, and this the Copilot giving us the answer here, but it's going to return the Keccak, and this is where the Keccak 256 function comes into play. And this is just another thing that we need to add on top of it, which is ABI encode packed. Now, this is just for pure development, like for pure development environment here. Like this is for pure development purposes. And inside the encode pack, we would throw the inputs in there. Cool. So we have got our function ready. Now, if you've never worked in Solidity before, you have to compile the simple, in this case, the simple contract, which is what I call my contract here, and then we need to deploy it. Now, if you're following along, make sure you are in the Remix VM, because we don't really want to deploy this to a testnet or a mainnet, and just basically leave the default settings as they are. Then we're going to deploy this contract, and we can see that the contract has been deployed. If we click on the contract, we can select the get hash function, and let's say, for example, that we want to hash, for example, the very typical hello world. Okay, we're going to call this function, and there it is. Here is the hashed output. Now, this is, let me zoom in a little bit, see if you can see it better. This output is the 32 bytes output that the Keccak256 encoding returns. Okay, and this is basically encoding this specific string. Now, let's add another letter D, and let's call this function. Just pay attention to how much this output is going to change, okay? Boom. Completely different output, and we just did one D added to the end of the word. Okay, so let's go back to normal. And as you can see, it is the same output as before, because the Keccak256 algorithm is deterministic, meaning that the same input will always produce the exact same output. So I hope that clarifies things a little bit with the Keccak256 function and the Keccak256 algorithm. Now, it is important that you understand these concepts, especially if you are into cybersecurity or cryptography, but don't stress yourself. Like, don't really stress about getting it the first time. It is quite tricky to basically understand it. It has taken me a long time. But basically, the Keccak256 algorithm is an algorithm that allows you to generate deterministic outputs based on specific inputs. We can hash pretty much any piece of data, any piece of information. They can be, like I said, strings, numbers, they can be functions. And yeah, it's basically a hashing algorithm. Super common when it comes to Ethereum development environments with Ethereum applications, especially more specifically with like signatures, airdrops, and like I said, if you don't know what this all of this means, don't stress yourself. Just basically, if you have to take anything away from this video, the Keccak256 algorithm is an algorithm that allows you to hash data in a deterministic way, and it is used for data immutability and data security and integrity. Okay, so that is it, guys. Thank you so much for watching, and I hope you got something out of this video, and I'll see you on the next one.